Okay, right. I think I am audible to you guys. Jedrick Solomon, am I audible?
Hello? Yeah. Were you waiting for
Okay,
us to talk about
okay, right. This is the thing. Now, now you are willing to have this session for your researchers, the support for your researchers. So I want to know the things. What are the things that you want to know? Anyway, I will start all of those things from the very beginning, and I will continue like that way. So can you give me a little bit of background of you? Uh, shall we start from Jedrick?
Hi. Sorry, my
Hi,
resume.
hi.
My background is in
Well,
um, in
that's
clinical
nice.
care.
Yeah, that's very nice.
My background is in clinical care. I'm a registered nurse, and I got my bachelor's of science in nursing. I'm a founder this company called a Caregiver AI, which essentially is kind of like, think of Alexa, but a caregiver in all kind of contexts, right? So essentially, I'm trying to automate my clinical practice to take care of people experiencing caregiver burden. So it's really personal to me. I've been a caregiver, so I'm really looking to explore how machine learning is applied through a technical sense, because all I'm reading is things that are, in articles, and I'm doing like a research and development for the startup. So learning the technicalities of it would be really good when I'm talking about frameworks with engineers. That would be really helpful because they seem to think very differently than I do. So it would be really, really cool to learn, I guess, the state of the art of things. I'm sure you are aware, so that would be really, really cool.
Yeah, right. That means you a doctor or are you a biomedical engineering field? So how should I define you? Or the how should I address you? Is that you are a doctor or you are in the biomedical engineering field or the nursing or clinical area?
Yeah, so my experience is I'm a registered nurse in the medical intensive care unit. So I'm not a physician. I'm not a PhD student. I'm a master's student. I'm a graduate student. So
Good.
yeah, I'm not a PhD.
Okay. Right. So how about your machine learning background? You are still learning. The have you know something about machine learning or you are still studying?
I'm still studying. I'm reading up on natural language processing, which is pretty. I haven't got to the specifics of algorithms, like what people use, particularly to do the thick of it. My startup requires, I guess, the engineer to like embed like code tokens, because it's going to be very, like, we have to make our own program, but once that program is made, it needs to be, so it's like the two components. So I'm not really, I guess, apt to the technicalities of it.
Okay, right. I understood that. Solomon, is there a possibility to you to also talk?
Yeah,
Okay.
I hope you can
Right.
notice. It's just
Hi, Solomon.
unfortunate.
Yeah.
I just come outside of the
Uh,
noise here, but I hope we can manage a little bit of the. So I'm Solomon Yamwaifa. I'm a chemistry PhD student at Wayne State University, Detroit, Michigan. And it's very fortunate that this my research program, like research, is going to be basically using machine learning algorithm. Yeah, so what we are doing is that it's like computational chemistry, okay, and we are going to computational chemistry of some biomolecules, fluorescent molecules, and there is the need to get a very large data set of like
Turn your Bluetooth off, Ashley, please.
Hello.
Yeah. Yes, Jedri, did you tell something?
Can you hear
No,
me?
sorry, I forgot to put myself on mute.
Okay.
Oh, okay.
Okay,
Yeah.
cool.
Yeah.
Solomon, you can go ahead.
Yeah. So it's like so we have to get a large data set of the fluorescent molecules and then see if we can tune the properties to our desired properties in terms of maybe like quantum yield. I know like I'm talking about some terms that I don't know, but like it's all about like how machine learning can be used to improve certain properties in the biomedical or in bioimaging field. Yeah, but I'm completely new to the field, and right now it's just like maybe literature reading or maybe like reading about machine learning, but I've not really gone into the computation, like maybe the coding aspect of it. Yeah, so right now I think what my advisor is doing is trying to make us learn Python. Yeah, of which I'm also a beginner in stuff because we'll be using Python stuffs for the machine learning stuffs. Yeah, so basically I'm very new to the machine learning, but that's what I'll be using in my research throughout the whole PhD program.
Okay, cool. That means, Solomon, you are willing to have the support for your PhD research here. And I want to know, Solomon, how is your Python background? Have you studied Python, or for Python also you are very much new? How is that?
For the Python, at least I can run some functions and a little bit, but not like very much. So like let's say I'm a beginner. Yeah, kind of.
Okay,
Yeah.
okay, right. Jetri, how is your Python capability? How is that the Python and the other programming languages for you, Jetri?
Yeah, can you hear me good?
Yeah, yes. I didn't get it.
Oh, perfect.
How is your Python programming language?
So I am also learning. I'm a student right now.
You are also new to Python.
I'm a student. Right, I'm new to Python as well. Yeah.
Okay, right. Okay, cool. So I understood the way I should go. So since Solomon is very much new to the machine learning, we'll move from very basic level and we'll go to very deeper level. So I feel like the Sri Lankan groups or the Asian groups, they will be finishing this session after 25 days. But for you guys, we will continue this thing for very much deeper level because since you are since you have passed the graduate levels, I think you can understand many things. And also we'll move to like the research levels with the by having the research papers and understanding the gaps. We'll move to some productive levels according to your areas. We will
I'm sorry, I'm
discuss
not
this
paying
thing.
attention.
Sorry.
I'm sorry, I was talking to my sister. She was trying to show me something. I apologize.
Right. Okay. Right. Okay. Okay. Cool. Then I'll start from the very basic level. So I think that sounds good. Shall I share this screen with you guys? The same content I will start, and after finishing these things, we'll move to the deeper levels. Okay, we'll start with our syllabus and we'll finish that one first. But we can, I believe that since you are a graduate level guys, you can understand more things if we start from the very scratch level. So guys, this is the my machine learning 25 days series. This is more into the industrial level, but for you guys, it is it should be more into the research levels. So I believe that I want to change some parts here. So here, guys, we are learning the machine learning techniques. Okay, as machine learning techniques, when we are considering about the machine learning techniques, we will be learning not only the algorithms, we want to especially understand why are we using these concepts, all of those things, and also the product life cycle. Okay, machine learning product life cycle. What we are discussing is how to step by step release a machine learning product. So that will be benefited you, both of you, because at the end of your researches, ultimately your aim should be somehow release a product. So I will be discussing the entire flow of the machine learning, and for specific scenarios, how do we apply the machine learning, and also how do we especially find out what is the best model for these things. Okay, so this is the intermediate level, what we call a machine learning course, but I will drive deeper into this one more than the intermediate level. So I understood about you guys, but I didn't tell about me. I am a research student, and also what we call, I have applied for one of the Ivy League colleges called Princeton. I think Jedri is very well know about these Ivy League colleges. So they have accepted, and I got the what we call the offer from this fall batch to get into that one. I'm currently following one of the programs. After finishing that one, I will be joining for that one. So because they have fascinated about my machine learning skills and the skills related to AI. That's why they have given me the offer, because for Asians, it will be very difficult to get into the Ivy League colleges. So I believe by having these set of skills, I can do a good job for you. That means I can give a very great support for you guys. So guys, what is actually machine learning? The simplest way of mentioning machine learning means we are allowing computer to learn from data. We are allowing computer to learn from data. It is a field of statistics. Okay, it is something related to statistics, and we are using statistical concepts, techniques, and allow computers to learn from data. Okay, and also there is a difference between normal software engineering and the machine learning, because in the normal software engineering, what they are doing, they are explicitly programming. That means they are more into the coding part. But you guys, if you are in the machine learning area, you do not want to thoroughly engage with the coding, because we are using the statistical techniques. And after that, we will be, Solomon, this meeting will be, anyway, it is live streamed and it will be in my YouTube channel. So after finishing this session, anyway, it will be recorded. Okay. And your participation also, it is automatically detected by the algorithm that I have made. So remember to put a like and comment in the what we call the YouTube. I will send you the link. They are only by considering the likes and the comments only, it will be auto-generated. It will be auto-detecting your participation for this class. So remember not to put a single comment like great or understood. If it is a single comment, then it is rejected. It will be auto rejected. So something like at least 2 words, meaningful thing. Put then then it can understand you have participated. Okay, right. All of those things I will teach. How those things are working. Those things I will teach. So guys, I have to roughly explain about the machine learning. So guys, this machine learning simply it is learning from data, and there is no explicitly programming. And also, guys, remember this one, especially there is some data, and this data plus algorithm. We are using predefined algorithm. Also, we are using user-defined algorithm. For you guys, especially Jedri, we want to know how do we generate our own algorithm. Okay, so we can't just jump into that part. We have to step by step go. We want to first understand about the predefined algorithms. After that, we have to understand how do we generate our own algorithm, and also how do we make our own machine learning library. Like that way we have to go. So guys, machine learning means data plus algorithm. If we use our data and algorithm, we will call it as a model. By having this model, we can do the predictions. Okay, does it like this way? For your problem, Solomon, it is fluorescent. I don't know about the fluorescent. Suppose it like something you want to give a prediction related to fluorescent.
Yeah,
You are
prediction.
yeah.
Prediction.
You want to do some predictions in fluorescent. Just give me a rough idea about what is this fluorescent. Then I will tell how it is the way it will be applied for this one.
So we have fluorescent. So we have so we are applying it to, let's say, DNA molecules. Okay. So we have a fluorescent molecule. That is, when you say fluorescent, meaning that that molecule is capable of absorbing light and emitting the light. Okay. So once you absorb the light, you can emit it, and it's applied in bioimaging, such that you can be able to attach it to a non-fluorescent, let's say, DNA molecule or RNA molecule, and you'll be able to detect that thing. You can be able to detect the DNA, so that in case maybe there's a photo damage or DNA damage or anything, you can be able to see it very well. And then so some of the fluorescent molecules are, let's say, red shifted or blue shifted. So sometimes you want to improve upon the properties of the fluorescent molecules. Some of the molecules are not that fluorescent, and some too are very highly fluorescent. So in this case, we just want to see a list of whether when non-fluorescent, least fluorescent, highly fluorescent molecules. And then now we look at, so when we get a database, now we can input an algorithm, which when we have any other fluorescent molecule, based on certain properties that we have, so maybe let's say quantum yield or maybe any other properties of that fluorescent molecule, we can be able to predict other, like let's say, functions, or it can be able to detect the fluorescent nature of any new molecule that maybe we can have or something. Yeah.
Okay, right. That means you are getting the data set, isn't it, related to the fluorescent first by your, yeah. After that, you want to go for get the insights of that one related to those molecules, isn't it?
Yeah. Yes,
okay,
exactly.
Right. Okay, right. So that you want to use the machine learning. Very good, cool. Now, suppose that Solomon has his data set. That is the data. So after that, we want to find out for that data sets, what is his aim. Now he has to get some predictions. So according to that, we want to apply a certain algorithm for that one. So his data set plus the algorithm what we are using, we are building a model. After that, we want to train that model. Okay. By training that model, now he has a set of data, but when the new data is coming, he has to give some predictions by using our model. So that only we are using the machine learning. So here, what is the case? If we use this data set and by mixing with the algorithm after generating the model, we can auto predict the things for the future perspectives. Okay, so we can't do that thing by the normal software engineering, because normal software engineering means a manual task. But for these type of tasks, we can use machine learning and we can do the predictions. But in that case, we have to go deeper into the machine learning. Okay, we will be calling it as like a deep learning, because now his data sets, even though some data is available, many of the data, those are unstructured data. So getting insights of the unstructured data means we want to go to the deeper level. That means the neural networks we want to use. Okay, so all of those things we want to learn. What are those, the fundamentals of the machine learning, and we have to go like that. So we in the machine learning, when the data is available, we are using an algorithm and we are building the model. Okay, by building the model, we can use that model to identify the insights. So we can consider it as generating a pattern. Okay, after that, if we give new data to that model, that can predict the things. That means that can give the output. Okay, that is the normal hierarchy. So I want to explain a little bit about this traditional programming versus the machine learning. Traditional programming, guys, we are sending data, and also we have to make a program. Okay, we have to make a program also in the traditional programming. Then in the traditional programming, it will give output. But in machine learning, what we are doing, we are giving the data set. We are giving the data set. That means in that data set, we will be having what are the inputs, and also what are some outputs that we have gained. That input plus the outputs, we call it as a data set. We are having that data set. After that, we will mix with the algorithm with that one. That means we have generated the model. After generating the model, it will give us a program. That program is called the model. After that, by using that model, we can do the predictions. This is what is happening there. So you give the data, you give the program. That means you are the person who is building the logic. Okay, you are the person who is building the logic. Then automatically, what will happen? Output will be generated. Right. In machine learning, what will happen? You give the data. That means you are giving the data set, complete data set you are giving. Okay. But you do not build the logic here. You are not going to do any coding part here. Logic is automatically generated. Okay. Then what will happen? After mixing with the algorithm, the logic will be automatically generated, and you do not want to again build up the models. By having that specific model, it will allow you to have the predictions. So I will explain this difference with by using a very simple scenario. Guys, a very simple scenario. This is like a simple addition problem. 1, 1, 2, 2, 2, 4, like that with very simple data I have taken. Okay, just to explain you. After that, now this addition problem, if we use like normal traditional software engineering, also you can use for this type of things, very simple thing. But if you use normal software engineering for this type of purposes, if there are some features, now you can see like data in the data sets, you will be having a very high number of features, the columns. Okay, in a data set. Now here, how many features? X is one
Excuse me?
feature, Y is another feature. Yeah, sorry.
I have a quick question. I was just I'm listening to your example, but I'm looking at the slide, and I just want to ask like a clarification question. Um, you said
Yeah,
traditional programming and machine learning. Uh,
yeah, yes, sir.
there do you did a distinction, right? So the traditional programming, you're basically making the algorithm yourself. In machine learning, you're using algorithms which are already out there, right?
Sorry, I didn't get it. Again, can you please repeat
Yeah.
it?
Yeah, so in traditional programming, you are essentially the programmer, right? Like you're building the algorithm yourself, right? Like you're building the logic, you're building the
Yeah,
algorithm,
yeah, yeah,
right?
yeah,
In machine
yeah.
learning, the input is the output, and the algorithm is something that's already been made. You're not really like building the algorithm yourself, right? You're trying to find insight from algorithms that are already made from that machine learning program.
Yeah, in the machine learning, we are not what we call, we are not programming something. As an example, now I will explain that one by this example. Okay, then you can understand that one. Like now here, suppose like this X and Y, two features, and by adding this one, you can get the sum of that one. You can use this normal program to do this one. So that what you have to do, you want to make a program for this one. You want to make a program for this one. Okay, suppose like you want to add three numbers, then you want to make another program for that one. If it is a four numbers, you have to make another program. That means when the features are more and more, what you want to do, you want to make programs case by case. But in machine learning, it won't happen like that way. If you have made the logic for two numbers, you after feeding into the what we call your system, allowing your machine to understand about this logic. After that, uh, they will auto-generated for other features. That means you do not want to provide always the features there. They will learn itself. Okay, that is the wonder about this machine learning. Okay, now traditional programming, what do you want to do? You want to feed everything. You want to not just feed it. You want to write the programs also. But we are not writing programs. We are explaining you have to use these features. You have to use these features on. Okay, I will show it by the part as well. Just give me 1 minute. So here we are using the Jupyter. In the Jupyter means for Python, it is a special editor we are using to get our write our things. That is the Jupyter. I will explain how do we code in the Jupyter, because all of those fundamental things I will teach you. But here just an example. So this is a simple addition program. So you can go to this one. And see here, this is the model that I have built. Okay. Okay, yeah, this is a step by step, and this is a ready-made step you want to go. After understanding this step by step methodology, you can build up the model. Okay, then after that, if you run this one now, since this error is coming, that is the one error of the Jupyter notebook. If it comes, you have to restart and run all. Okay, you can run like that. Right now, you can run it again. Okay, now you can see a small interface here. There, now you have to enter the first number, like 12. I will say like now I have taken like 1 to 20 numbers only. Now I will add something. The big number, we'll say that 324 and 56. And if it like that, it will give the answer. Okay. Now, if we, this is the thing which is happening in a simple calculator also, but in a calculator, if you want to add more things, if you want to add more features, okay, you want to again, you want to make the program there for that 3 or more numbers as well. But if I ask, if I give the basic instructions for machine learning model, we don't want to feed for 3 numbers, 4 numbers like that way. They will learn from that data, and after that, what will happen? They will predict for more features as well. So, as an example, another example I will take. Now, if you want to classify dogs and cats by the images, okay, dogs and cat by the images, in the traditional programming, it is highly impossible thing, because now suppose like you are having 1 millions of the dogs and 1 millions of the cats, and if you ask another dog which is not available in those data, in the normal software engineering, to identify that dog, it is an impossible task. But in machine learning, we can use that dogs and cats data sets, and after that, if we give a new dog, okay, which is not in that data, they can figure out, yes, this is a dog. Like that way, it can figure out. We call that thing as a image classification. Okay, we can easily use some kind of technologies and identify that one. Again, we'll move to the our what we call slides. So, guys, there are this machine learning we can use for various tasks. As an example, now the one of the new scenario in the Solomon's thesis report, he's asking to have the fluorescence, the insights of the fluorescence. Okay, for that one, and also in the civil engineering task, the insights of the concretes. Anyway, any types of areas you can use, but the machine learning is very much suit for some impossible tasks in the normal programming. Something is like email classification. Like email, now you know that your email, it can be some email can be considered as spam and not spam emails. But converting spam and not spam by traditional program is a very difficult thing, because now you know that if the subject is not available, it can be spam. Okay. If it is like that, you have to write a special program for if else statement. If the subject is not there, it has to convert as spam. But then what will happen? All those subject is not available thing will be going to the spam list. But if any case, if we just miss the subject, that will go to the spam list. But normally it won't happen. In our cases, when we are getting unnecessary email only, it will be going to spam list. So the reason is machine learns how is the behavior of the spam email. Okay, so those type of tasks we can use machine learning. Okay, and also one good example is the image classification. So as the way I have told the cat dogs classification, we can use a very easy algorithm, one thing called the convolutional neural network, the deep learning algorithm, which is in a subset of the machine learning domain. We can use it and we can classify the images easily. And also we can use machine learning for data mining, not data analysis. Before to move to the data mining, I want to explain a little bit about the data analysis. Data analysis means, guys, identify the hidden patterns by using a simple plots, visualizing techniques. As the way I have shown here, this is a simple visualization, guys. Okay, by using these plots. By using the visualizing techniques, identify the patterns of the data. We can call it as the data analysis. Okay, guys. But in some cases, you want to have deep insights, as the way Solomon's fluorescent thing, because he has to identify some deep insights. But by just having simple visualization techniques, you can't get those deep insights. So that what you want to do, you can apply machine learning things. After that, you can come to some kind of predictions. After that, you can figure out what are the insights of there. Okay, so the deeper insights of the things you can use machine learning. So we call that part as the data mining. Now, guys, the machine learning not start very recently. It has actually started from 90s. The very early 90s only it has started, but it has a paradigm shift of like very rapid increment in like after 2000. The reason for that one is that we will be getting affordable hardware resources, and also internet speed is very much high, and the very much important thing is the evolution of the algorithms. Okay, algorithms has evolved very fast after 2000s. In the 1990s, they have identified the decision trees. After that, the generation of the algorithms has become very fast. So these days we can identify the machine learning. If you understand the machine learning basics, then you can create your own algorithm in a very efficient way. So we will be having some libraries to generate that, and also the storage facilities. Okay, those days you are storing all those things in your premises. Nowadays we will be having the cloud storages, the cloud computing techniques, so that the storage facilities are very convenient. This thing also we want to understand: CPU versus GPU versus TPU. Central processing unit. CPU means the central processing unit. Every computer has a central processing unit, and if we central processing unit is not a specialized thing. It is for general purpose computers. It is not for machine learning things. If you are running your machine learning model in a CPU, it will be like very slow because it has the average speed only. But this GPU means the graphical processing unit. It is when you want to render images, it will give those things very fast. And TPU is the tensor processing unit. This is very much suited for machine learning things, and it is specialized for machine learning and the deep learning things. So CPU, it is versatile, but it for general purpose things, not for the machine learning task. GPU means you can render the images very fast. It is specialized for arithmetic things, and also you can use it for the graphical machine learning tasks. So normally in your computer you will be having a GPU, so you can use the things. If you do not have a GPU, you can work with Google has provided a platform called Google Colab. There you can hire what we call the TPU or GPU, then you can run the code fastly. Now NPU, that's the third thing. NPU means a neural processing unit. Again, I told something like TPU. That TPU belongs to this NPU category. TPU means tensor processing unit, that belongs to this NPU. NPU means neural processing unit. What is doing there? We are using this for the deep neural networks. Okay, if you want to run deep neural networks, you want to have NPU. Like several companies, they have provided their NPUs. As an example, Alibaba, it is Ali NPU, and Intel. Yes, Jedri?
You're giving examples about some of the NPUs. Do you happen to know what Alexa uses? Like
Alexa
it's like
uses,
the,
I
their
think,
own.
we will figure out
Sorry.
that one. See, I'm not sure about that one. We'll see. We'll see. Alexa, what they are using that one.
Okay.
We'll see.
I'm just curious, like what virtual assistants, like what type of like. I'm sure everything's in the cloud,
Alexa
right?
is Amazon, isn't
So,
it? Yeah, Amazon. Amazon, I think it is FUGA. Alexa. Amazon, I think they will be having their own NPU. Amazon.
right. That's what I was just.
Amazon. Aha, this one. I've seen something here. Amazon using like something called AWS Inferentia. So Amazon domains, they will be using that one. So Alibaba, it is Ali NPU, and we'll see about this one. The Rockchip is this one, NVIDIA this way, like that way. So basically, for Apple, it is Neural Engine. So since Alexa belongs to the Amazon, it will be using this one, NPU. Is that okay?
Oh wow. Okay. Okay.
Okay. Right.
So that's stating that's simply they have like pretty much their own. That's what that means, right?
Yeah. Okay. Right. So then, guys. This is a simple overview of the all the AI applications. Now, whatever we are doing in our things, we are making an AI application. That means for your convenience, we are generating something, our task, how to automate our tasks. Okay, so that thing we are calling as an AI application. We are releasing a product which can do our task easily. So that we are using the techniques called machine learning. Under this machine learning, there is a specialized domain that is called the deep learning. Deep learning means now if we have if we want to figure out some unstructured data, okay, if we do not know anything about some data, okay, and by feeding more data, we can get the insights of that one. So that part we are calling as the deep learning. So like in the Alexa, if you want to see the what we call the voice recognition, okay. So if you are taking some, if you want to make the virtual assistants, okay, you want to have some data sets, okay, by doing some research. After that, you can use this deep learning techniques and you can get the insights of that one. So that we want to verify what is the difference between now this human intelligence and the artificial intelligence, AI. Now, guys, we will be having some capabilities. One thing is the pattern recognition and the intelligent quotient, IQ, and also the EQ, emotional quotient, and also the creativity and the imagination. But this creativity and the imagination, still AI cannot do that one. Emotional quotient also cannot recognize the emotions properly still. IQ, in some extents, they can do. But this thing, pattern recognition, they can do it very well. Okay, that's why for normal applications, voice recognitions, some detections, okay, some classifications, they can use this AI. Okay, so our main goal is how to recognize patterns. Okay, so our scope is limited to recognizing patterns. So we'll discuss about the evolution of the AI also. Then we can understand the basically where we have to go. Okay, what are the things we have to find future. The AI evolution start from something called the principal component analysis (PCA) in 1901. This principal component analysis means, guys, if there are more features, okay. If now see that you are having a data set, you will be having a data set. You will be having very high number of features. If you have very high number of features, some features will not directly involve with your result. Okay, but you are not sure that is this feature is feature or not. By just removing that feature, you can't sure that you are getting the accurate result. So you have to have that feature also, but you have to limit that feature so that what you can use, you can have, you can combine two features and generate one thing. Okay, what you can do, you can, I'll show you like that way. Now here X and Y is available. Those are the features. Okay, suppose that there are like hundreds of features like X1, X2, Y1, Y2, like that way, there are hundreds of features. Now, by having XY only or XYZ like that way, you can make a plot and you can have visualization. But if it is like hundreds of features, you can't have a visualization. Difficult. So in that case, how can you do? You can merge two features and generate one. The next two also you can merge and have one. After that, again, merge those combinations also you can have that one. That means you are shrinking the features. This shrinking of the features to one area, we are calling as a principal component analysis. So when we are moving to deeper insights of our data, we won't use this technique called principal component analysis. Okay, guys. We can say that it is a statistical methods and reduce the dimensionality of the data. Dimensionality means, guys, it is the features. Okay, it is the features available in our data set. So what you are doing, you are shrinking. That means you are reducing the data. And after that, there is a concept called the perceptron. Actually, this perceptron is the starting edge of our neural network. Now, suppose like this way. Now, our ultimate result is how to mimic the human brain. Scientists have identified that the brain power is happening because of the neurons in our brain. So what they have done, they have artificially generated this neuron. It is called the artificial neural network. Okay, this perceptron is the starting edge of that neural network. After that, the something called the fuzzy sets were available. Fuzzy sets and the fuzzy logic means, suppose like in the Boolean algebra, I will show you that one. Boolean algebra. Now, suppose this is a decision you want to make. Is it called? Now, if you are using the Boolean logic, you can get only two formats. It is yes or no. That means for yes, it will be given 1. For no, it is giving 0. Yes and no, only 1 and 0. But later on, they have identified. Now, is it cold means, yes, it is cold. No, it is not cold. But it is like a sensation. You can't like there. You will be having like, yes, yeah, I'm okay. It is cold, but I'm okay. There is a variation of your sensation. So Because of that, you can't just say 1 or 0. So there can be some values in between that, some real valued numbers. So identify there are some levels in between those things. That means there are some continuous values, some decimal values also available in between. That is called the fuzzy logic. Okay, by using that fuzzy logic is the fundamental to the machine learning. By identifying there is a level, there are some in between levels, we can move to the further domain, that is the machine learning domain. So after that, something called like the back propagation, that is the second stage of that, something called the perceptron. The second stage is the back propagation. Then the machine learning algorithms, the decision tree algorithms, support vector machines, random forest, like that way, there is evolution. We will be discussing all of these things. Okay, what is this decision tree? Okay, how do we use this decision tree? What is this support vector machine? What is this random forest? The convolutional neural network? What are these things? We will be deeply discussing. Okay. The evaluation thing we can easily classify into 3 categories. The symbolic AI. In the symbolic AI means actually there is no AI. Those areas people do not know anything about the AI, what we are meaning today. There means now if you want to get into a decision, you can write giant codes of if else. Okay, by that way you can get some kind of decision. Okay, by writing like if else, if this happens, this is the answer. If it is not, this is the answer. Like that way, write in series of codes, you can understand about some, you can get into some kind of decision. After that, they have developed something called the expert systems. Expert system means you are having the knowledge of the expert. After that, you are converting that into a code. Okay, that is called the expert systems. By using that expert system, they have generated the chess master. Okay, by that, by using the chess master application, they can beat the champion, also those areas. So that is the expert system. Then the fuzzy logic. Okay, by using the fuzzy logic means it is related to statistics. Related to something, statistics means it is the foundation for the machine learning. So like lung cancer detection, those areas, we can use the fuzzy logic. Okay, you will be wondering now, fuzzy logic and the machine learning. What is this difference? Machine learning is a technique, guys. Machine learning is a technique in the AI field. And why we are using this machine learning? To give better decisions. Okay. Fuzzy logic means it is a process. It is there in the machine learning domain. Okay. It will help you to get the conclusion. That means it is a methodology. Okay. It is a theory. Fuzzy logic means it is theory. That theory will help us to get the decisions of our technique. Right. Now we'll see what are our main tasks of AI. One thing is the classification. We can make all of these AI parts into these 5 things. Okay, these 5 things. What are these things? Classification. Okay, you are classifying like dog and cat. You are classifying dog and cat. Okay, but remember, in the classification, you have to know what are your outputs. Okay, dog and cat classification, you know what are the outputs that you are gaining. You are getting the outputs as dog and cat. Right? The like email classification, you are getting the output as spam email and the not spam email. Okay, and the predictions. Now, Solomon's thing, he has to make some predictions so that we can use. And also a simple general example I will tell for this predictions. Suppose you want to predict your house price. Okay. Then by according to your square feet area, when the square feet area is high, this is the house price. If it is low, this is the house price. Like that, you can move into prediction. Search. For search, using virtual assistants, you can do the searches, and using the search engines, you can do the searches. All of those things, machine learning is involved. Optimization. Optimization means you are how to make the accuracy high. Inferences means getting new knowledge. Now the researchers, the people who are in the researchers, what they are doing, they are using machine learning techniques, and they are deeply driving them, and after that getting new knowledge. So, but guys, all of these things are appropriate. You can't get the 100% accuracy, but you can move something. Yes, Jedri.
Hey, I think I missed, you said optimization was to make the estimation better.
Right. Yes. By using optimization, you can make the estimation better. That means actually, guys, this optimization is not a machine learning technique. Okay, it is a part of the AI. Okay, it will help us to increase our level of accuracy.
Gotcha.
Is that clear?
Yeah, quick question. I want to use a hybrid approach for my startup utilizing the current state of quantum processing, which we can use like Boolean type of responses to optimize, like, because my AI, I hope it's able to process a lot of data. So I want to use like the quantum simulation that's going on. When we do like a hybrid thing in optimization, how does that work? Because you have to go from one classical computing to the other, and then from that back to the other classical computing to be able to use it right in the system. How is optimization like? I guess my question is like, what is the technical process of that occurring? Like when you go from classical to quantum, and then from quantum to classical, does the optimization happen in one system in the quantum, and then in the classical again to make sense of what happened in the other? Does that make sense?
I didn't get the question properly. Tell me, is that you are asking when you are moving to the what we call the quantum things, how is the way you are supposed to optimize the thing? Is that the question? Or
right, like optimization when you're thinking of like not just classical computing but quantum optimization, so that you can, by using the quantum optimization, you then can optimize even better the classical, which we have hardware.
Yeah, definitely the quantumization, the optimization will be better, but you want to use the right techniques only. Okay,
right,
and that is also based on the scenario. In some cases, the classical will be stymied. Okay, but that is the based on the scenario. So we have to consider that one, and we have to run a trial and understand that.
Okay, let me give you an example real quick. So like for the startup, I want the artificial caregiver to be able to detect whether the scream is going to lead to aggression. So it's kind of like predicting, but then it's kind of like a Boolean type of like, is he screaming yes, no, right? Is this screaming, high pitched, like, aggressive or not? So it's like, that's the optimization I'm trying to use so that, we can process more data faster using the quantum processing and then bring it back to the classical. And I guess, is that optimization itself, or is optimization just within one system, or can it be like a general term? I guess is what.
Right. That means it will be like that optimization will be a general term.
Okay.
Right. Okay. We will discuss more things. Okay, you will understand scenario by scenario, and also that will relevant to you, and you can understand that one. When we dive deeper to that one, you will be understanding those things. Okay.
Okay.
Right. Okay. You are very enthusiastic about these things, huh? Cool, huh? Good. Very good. I like to have these type of discussions with you. Okay, very much. Ask those things. Okay, then I can also get some things from you, right? Uh, so, guys, yeah. Jedri, you will understand something from this diagram. Okay, now here, this diagram, this is the whole process of the AI. So this the AI, it has this logic. You have to have a logic. Okay, so that logic, basically we will be using this decision trees, DT path, and also the fuzzy logic. We can use either fuzzy logic. Okay, we can use various logics. Okay, for the quantum things, we can use various things, and also the reinforcement learning. Reinforcement learning means it is a part of the. We can say that it is the technique that we are using for robotics. Reinforcement learning means we are not providing data. We will allow the environment to feed the data. That means the system will learn from the environment. That is called the reinforcement learning. And you want to have the statistical background. That means that you want to have the data, statistics, and the probability. And you want to have this classification techniques and the encoding techniques like principal component analysis. And here, what is this? This is our optimization part. Now you can see now GA, this genetic algorithm, it is part of our AI part. And some kind of optimization is irrelevant to the AI. You can see it is like this kind of boundary. That's why I mentioned you want to have the right optimization technique. And here, artificial neural network, there are some techniques called SOM and also the deep learning techniques. Okay, right here. So this is the complete overview diagram of the AI. Now see this one. Now this is the machine learning domain. Here you can see the red color boundary. Here we have removed this optimization thing. That means this optimization is not a part of the machine learning. But to do the AI application, we can use the optimization techniques, but it is a separate domain. And also this fuzzy logic is not relevant to the machine learning. Okay, so machine learning means this boundary. Right. We'll get a brief idea about what is this deep learning. I told deep learning is the subset of the machine learning. Okay. Deep learning is very well suited for unstructured data. And if you are having very high data, which is unstructured, it will be good to use deep learning. Okay. As an example, now it is not only for unstructured data, you can use for the structured data like the dogs and cat images. As an example, now dogs and cats. Millions of records of dogs and cats. Okay, if you're having that type of data, you can easily use the deep learning. Okay, then it will give a high accuracy. But if it is less data, you can use the normal machine learning techniques. Okay, you can use the normal machine learning techniques. So don't always go for the deep learning. Okay, first of all, you want to understand what is your scenario. If it is a small scenario, you can use this normal machine learning techniques. But if you're having more data, then you want to go to the deep learning techniques. And remember, guys, in normal machine learning techniques, if when you are training the model by having more data and more data, after some level, your accuracy is not increasing more. That means it will be stabilized. That means in normal machine learning techniques, when you train the model by using the data, after exceeding some limit, your accuracy does not increase. But in deep learning, when the data is more, your accuracy will be increased. That thing will be explained by this graph.
I have another question about this. Excuse me.
Yeah.
So are you explaining overfitting?
Yeah, overfitting. Yes.
Okay, okay.
Okay, that is very good. Yeah, you have some knowledge. Cool. Okay. I will be reach into that one also. Now that means it will be overfitting. Okay, if you are giving the data again and again and again, what will happen? After some level, it will be stabilized. Okay, they fully confirm, saturated by the data,
Okay.
right? So it is like this way. The old machine learning techniques, it will be like this way now, but deep learning, it won't happen like that. When there is more data, it will learn by the data and it will reach more. Right, the machine learning, we can make into these 4 categories based on the amount of supervision needed. That means what is the amount of the supervision you need. According to that, it will be classified like this way: supervised learning, unsupervised learning, semi-supervised learning, and the reinforcement. I will come to these stages. Okay, by this supervised can be classified into mainly regression and the classification. Supervised means regression and the classification. Unsupervised mainly up to these 4 things: clustering, dimensionality reduction, anomaly, and association. We'll see one by one. What are these things? Here also I have mentioned the same thing by in a more meaningful way. We'll see what is this supervised learning. First, this simple scenario. I'm using this simple scenario. Now, suppose you want to you are having a data set of candidates. Now, the interviewers want to judge whether the candidate is selected or not. Okay, he's having some past data related to candidate's IQ and his CGPA. Because I have trained our guys for the industrial training. They want to have jobs, not like the researchers. That's why I have written down this example. So here the candidate's IQ is 135 and his CGP is 3.7. Like the placement is pass. Like that way, in some cases, it will be like fail. You can see here, you know the outputs that you are gaining. Okay. You know the output that you are getting. What is that output? Whether it is pass or fail. Okay, pass, it's pass or fail. Nothing in between that. If it is pass or fail. What can you say about this data? Are these numerical? No, these are not numerical. But we know what are the outputs. These are categorical data, isn't it? Pass and fail means just normal text data. We are calling it as categorical data. Okay. So if you are having this type of categorical data, or if it is a discrete data, but like not continuous data, like discrete numerical data. If you are gaining discrete numerical data, or if you are getting categorical data as your output, and if you know what is that output, we will be calling it is a supervised learning. Supervised learning means you know the output that you are gaining. Okay, guys? You know the output that you are getting. If you are getting the output as a continuous way, okay, that means decimal numbers also, that is also supervised learning. But this thing, this example is very specific. You have got the, what is that? Categorical data. And you know the output, and it is a categorical data. We call it is as a classification. Okay. In a classification, you are getting known output, and this known output is a categorical or it is a numerical discrete, can be numerical discrete. But if you are getting a continuous value as the output, that means real valued number, but it is a continuous. So that we will call it as a regression type of supervised learning. Regression. Regression means you are getting a decimal value. That means continuous values you are getting. Okay. As an example, house price detection with the size of the square feet. You are getting the output as the house price. House price is not just a numerical discrete value. It is a continuous value. So it is a regression type problem. Regression and the classification. Those are the main two domains of the supervised learning. Okay, examples for the regression: stock price detection, house price detection, maximum revenue generation. Those things are regression type thing. Classifications. Okay, in the classification, you can classify email spam classification and the credit card fraud detection. Those things we can say, those are what are classifying things, because you know you are getting some outputs, 2 or more outputs, but those are categorical or numerical discrete. Now we move to the unsupervised learning. In unsupervised learning, there are 4 domains: clustering, dimensionality reduction, anomaly detection, and the associate rule mining. This clustering means, now in unsupervised learning, remember guys, this thing, you are not getting the label data. That means you do not know actually what is your output. That is the actual required thing for Solomon's research aspect. Now, he does not know what is the output he is gaining, but he will be getting some kind of output. There is no label for that one, but he has to identify what is this label. So, he can use some clustering techniques for that one, or any other things like anomaly detection you can use. If there are some anomaly in your data set, you can identify why is this one like that one. Okay, those are the unsupervised. In unsupervised techniques, you are not getting labeled output. That means you do not know what is your output. As an example, now dog and cat thing, you know the output. Okay, that is a classification. But by using that fluorescent case, by using some certain algorithm, he can make those results into some clusters like group. But those groups, he does not know what is this one actually. Like he has got like 5 groups, but the machine does not know what are these 5 groups. After that, but it has divided into 5 parts because of a certain pattern. After that, Solomon can figure out what is this pattern. Okay, those things we can consider as the clusters. The dimensional reduction, as I told, like reducing the columns, that is also come under the unsupervised learning. Anomaly detection, if there is an anomaly or the outlier, okay, then also you can consider it as an unsupervised thing. Association rule mining means we can use it for, now you know that in the supermarket thing, the supermarket tracks a range in a particular order. In order to increase the buying psychology, they have increased. Walmart has done a research related to that one. They have understood that there is a pattern between baby diapers and the beer. Because when a single father is doing a shopping, when he is buying a diaper for his baby, and also he will buy a beer also. Some kind of relationship between this diapers and beer. And also some goods, there is a relationship. The people are willing to buy according to a pattern. Okay, that pattern is called as association rule mining. We will be discussing all of those things deeply. Yeah? Now, the first day we are giving an overview here. You have to understand what are the things we have to learn. The anomaly detection. Anomaly detection, I told that this kind of, now here is a peak point in here. This is a very much difference from the other things. Anomaly. And here also now this the crosses, and this cross is somewhere out. We can consider it as anomaly. Semi-supervised learning. Semi-supervised learning also we can use for some kind of researchers like COVID-19 thing, and also the Solomon's research also. If he could figure out some of the outputs, some of the label outputs, he can figure out. He can figure out what are the rest by using the semi-supervised techniques. Okay, that's why after understanding these concepts only, we can figure out what is the best for our use case. Here it is like this: semi-supervised learning. I will give some example. The Google photo labeling, very much convenient example view for you. Now in photos, in the Google photos, if you label, this is your father, this is your brother, this is your girlfriend, like that way, Google automatically label the other photos also. If your girlfriend is in another photo, that photo is also labeled by the name of your girlfriend. If your father is in another photo also, it will label that one. So it is like this one. You are giving a label for some data. The system will use that one, and it will give the labels for unstructured things as well. So, so these things, we are dealing with the hypothesis. By using some kind of known data, we will generate a hypothesis. According to that hypothesis only, it will predict the other things. That is called the semi-supervised learning. And the reinforcement learning. This reinforcement in learning, guys, it is, we are not providing any data. No input is available. Just take the driverless car case as the example. In a driverless car, when a car is driving automatically without the helping of the driver, so there is no data. How then the vehicle is moving? He will, the vehicle will learn by the environment. When there is a barrier, it will identify. This is a barrier. So if I move this one, I will knock. Okay, by computer vision techniques, he will identify. So there is a certain policies that we are providing. The policies are the rewarding system and the punishment system. Okay, if it knock with the barrier, there will be a punishment for the policy punishment, policy-wisely punishment. If it go in the right track, policy-wisely reward. Okay, according to that, those things are going. Normally, this reinforcement learning, we will use it for the robotic purposes. Okay, the most important thing is now the second classification, that is based on the production. Production means how we deploy the our product to the cloud environment. So there, or otherwise I can say, how do we train our model? What is the methodology of train our model? There are two ways of train our model. One thing is the batch learning methodology, and the other thing is the online methodology. In the batch learning methodology, what you are doing, you are taking your whole data set and you train that one and you deploy. After deploying, you are not retraining it again. Okay, that means after in the deployment stage, you are not retrained, but you can do it in the regular intervals. After getting, after having like 1 week, again take the data set, and with new data set, you are mixing that again. You are training. You can do like that way, but you are not training it in the dynamic way. That means after deploying, you are not training there. You are not training in the environment. Online training means you can train by in an incremental way. You are not totally take your data set. You can take some small part of the data set, then train it and deploy. After deploying, In the dynamic wisely, in the environment, you can train. Okay. So production means you are allowing your project to run in server. So the batch learning means you are here, like the system learns only once. That means you are giving your total data set and train that one. When you are giving your total data set means it will be time consuming, because if it is a large data set, it will be time consuming and also expensive in the case. This is you will be doing these things in your machine, and internet is needed only for the deployment purposes. You will train before the deploy. After the deployment, you are not training that one. Simple architecture diagram for that one. Data is there. You will be mixing it with your algorithm, and you will evaluate and deploy. If it is error, you analyze the problem and train it again, evaluate and deploy. But in the deployment stage, you are not training. That is the batch learning. In the online, this is the online learning. We say online learning. That means you will be dynamically trained. Okay, incremental wisely, batch by batch, small pieces you can train. You are not trained the whole data set there. Okay, so since you are not taking the whole data set, it will be fast. Okay, and it will be learned dynamically. But some kind of difficulties in this online learning, because you want to have some set of libraries there. Normally, batch learning is the easiest way, because we will be having ready-made libraries, scikit-learn, something called scikit-learn. We can do all of those things there, but that scikit-learn is not that suit for the online learning purposes. So that you can use separate libraries like something called River. Those things you can use. And also you have to careful with this parameter called the learning rate. Okay, if you do not provide the correct learning rate, that means there is a risk. That means the model will be trained by unnecessary data also, if you do not provide the right data, right learning rate. If the learning rate is small, model will be trained very small way. If the learning rate is high, model will exceed the limits and learn by the unnecessary data also. So you have to provide the right learning rate as well. Comparison between online and the offline things. Offline means that is the batch learning thing. All those things that I have mentioned, I have classified into these things. Some kind of applications for online learning is like recommendation system, because there you want to learn by the environment. Okay, you can get you want to learn the real time. But the general cases like now, as an example, now Alexa thing. They are Jedri. What is that? You want to get the real time data, isn't it? You are generating a virtual assistant. There, you want to have the real time, isn't it? Real time thing.
Correct.
Yeah. So, what is the learning methodology you have to use? Is that online or batch learning?
I believe that it would be best to begin with online, and then move on to like into the offline, because like I think once we know because the kind of caregiving thing, the complexity, I think it requires online.
Yeah. Okay. Right. Cool. Now if you want to get the things like that, now in that case you can use the offline things for the general purpose things. But if it is like if it wants to learn from the all those instances, you want to go for the online learning, isn't it? But anyway, even it is a complicated task, we have to use the right methodology for that one, because we will learn everything, so that you can get the idea about that one.
Right. My friend who is an engineer, he was telling me that my startup, just the framework that I'm thinking of, it would also require reinforcement learning, kind of like
Cool.
the virtual assistant also being aware of what is happening in real
Yes.
time,
Yes.
and it
Yes.
learning from the input.
Yeah, that's yes. It will be using reinforcement learning. Okay, that means we will be having nice project. We can
Oh yeah.
go with. Yeah. Right. Then some kind of drawbacks of the batch learning and online learning. One thing is expensive. You can say the one's way it is expensive, because you want to release your full data set. That's why we are telling that it is expensive, because some storage facilities you will be needed for that one, and time consuming, because since it is a large data set, it will be time consuming. And there is a problem of the availability, because this now once you have released this one, once you have deployed this one, you can't retrain again. Retrain it again within the boundaries. You can't retrain. But the online learning, it also has specific disadvantages, like you want to have a monitoring system for that one. Continuous monitoring is needed, and you have to have some additional libraries, and there is a risk. Risk means since you are in the online, there's a chance of learning from the unnecessary things. Therefore, there is a risk. So here, what type of learning would apply for this one? Like if it is a recommendation system, you know that you have to learn from the environment. So that we will be using online learning for this one. House price prediction things, it is not needed to have the real-time things, because it doesn't change the parameters very easily. Therefore, we can use for batch learning things. Okay, so it is the online learning and the batch learning. So that is the conclusion for today, guys. We will step by step learn all those things. Okay, Jadri, we will discuss your project because I think it will be a nice project, and I'm very happy if I can support you for that case. Okay, by supporting somebody only, we are also will be rewarded. So that is my way of doing that one. So you give this message to your USA guys also, if they are willing to learn machine learning free, they can learn and share this knowledge, because in Sri Lanka is in a crisis, guys. So only, but in Sri Lanka they will be having good knowledgeable guys. We want to provide this message to the world. That's why I'm doing this one. So you can support us by sharing this thing. Okay.
Of course. I'll tell a lot of my advisors to see if they got the time to join, because this was excellent. You did a really, really amazing job. You cleared up so much confusion between the definitions of these words, machine learning, artificial intelligence, love the graphs. So for sure, thank you so much.
Okay, there are a lot of things to go. We will learn step by step. Then I believe that you can make everything. You can do all those things by your own way. Trust me, I will do like that. Okay.
Sweet.
Again, do share these things. Okay, guys?
Of course. Thank you so much.
Thank you very much.